So what I'm going to do today is go over a few of the problems off the percentage increase and decrease homework assignment and highlight some important things to think about and maybe answer some questions that you might have been confused by. So let's slides. There we go. Percentage increase and decrease problems. So the first thing you always have to think about when you're doing one of these problems is which number goes where. And if you don't stop and think about which number goes on top and which number goes on the bottom, then you're just kind of guessing and you'd get it wrong at least half the time. And I don't know about you, but it always seems to me like when I'm guessing, I tend to get it wrong far more often than I should. So problem 5, you bought a certain stock when it cost $80 per share. It's now selling at $30 per share. What percentage of its value did it lose? So you've got to have either 30 over 80 or 80 over 30. And then subtract the 1. The question is, which number goes on top? So I want you to tell me your answer. Is it A or B? And how you knew which calculation to pick on the form. Okay, so I set this up with 30 over 80 minus 1, which is equal to negative 0.625. So the stock lost, that's the job of the negative sign, 62.5% of its value. And I always like to pause and reality check my answers. Notice that it went down by more to less than half. It went down by more than half. $30 is less than half of $80, which means its price must have gone down by more than 50%. So it's good that this is a large number. Now, how did I know it was 30 over 80 and not the other way around? There are 3 different ways I could think about this one. You're looking at change over time. It's usually the newer value over the older value. So I bought it at 80, that's the old value. It's now worth 30, that's the newer value. This doesn't help if you're not looking at time, but you often are, so that's a good kind of rule to have in mind. Also, we know this is a decrease. It's going down. So when you're looking at decreases, you have to be looking at the smaller number over the larger number, and then you subtract 1, and you end up with something that's less than 1. So decrease means small over large. And finally, we're asking that it's now worth $30, which is how much less than it used to be worth, how much less than $80. So the than part is what goes in the denominator, the bottom. So those are how I knew how to set it up. The second part of this problem says, okay, stock's worth $30. How much does it have to go up by to get back up to $80? So again, is that 80 over 30 minus 1 or 30 over 80 minus 1? Tell me your answer and how you knew which calculation to pick on the form. I'm going to go on and do this in a moment, but before I do, I want to point out it has to go up by a whole lot, right? It has to more than double. It has to increase by more than 100% of its value. So I'm looking for a really large number as an answer. It needs to be 80 over 30 minus 1, which is 1.67 or 167%. So we said that's more than 100%. How did I know? Well, again, new over old. In the future, I want it to be worth $80. That's the new number, where it's now, that's the older number, only worth 30. This is an increase, and whenever we're looking at an increase, you have to be looking at the larger number over the smaller number. And the last way to think about it is to say $80 is what percentage more than it is worth right now. So the value right now, the $30, is the denominator. So that's how you handle, those are ways that you think about which number goes where on one of these percentage change problems. And again, you always need to pause and ask yourself that question. Sometimes you might be looking at these problems and like, I don't have all the numbers that I need. How on earth can I do this? So number 6 said, you bought another stock that has lost 45% of its value since you bought it. You would have to gain what percentage of its current value for you to break even? Go back to the price it was when you bought it. You're like, I only have one number here. What am I supposed to do? So give me your thoughts on the form for how you would like do anything on this problem. So here's the key idea. If you're only given a percentage change and you're asked for another percentage change, that means it has to work no matter where you started. So you just get to make up a starting point and see what would happen from that starting point. So I could pick $17 or $593, but I'm going to be lazy and make it even easy on myself. I'm going to say what happens if I started at $100. So if I started $100, then when it went down by 45%, it went down by 45% of 100, down by $45, which is nice and easy because percentages of 100 are easy. So started at 100, down by $45, that means it's now worth $55. And now it's really a lot like the problem we just did. I have something that I bought at $100, it's now worth $55. How much of its current value does it have to go up by to get back to where it started? It's going to have to go up by a lot, but not quite 100%, because it doesn't have to quite double. So this will be my calculation. It has to go up by 100 over 55, new over old, large over small. How much more than the 55? 100 over 55 minus 1 is 0.82. It has to go up by 82% for you to break even. Now, another thing that comes up sometimes is you're not asked for the percentage change, you're given the percentage change. You're given one of the other two values. And a problem like this, it can be really tempting to start like writing numbers down and doing calculations with them. But again, I would encourage you to pause before you write the numbers down. Think about how these numbers are related, what the relationship between them is, and then plug in specific values and try to solve for whatever the one you don't know is. So here's a problem. In New Jersey in 2015, there were 9,743 robberies reported, which was a 7% decrease from 2014. The question is, how many robberies were there in 2014? So before I start doing any calculations at all, I want to reality check myself. Should my answer be larger or smaller than 9,743? I want you to think about that for a moment and give me your answer on the form. So since the value in 2015 is a decrease from the 2014 number, I'm looking for value in 2015, rather, say that backwards. I'm looking for value in 2014 that is larger than, that is more than the number of robberies in 2015. So I'm looking for an answer that's bigger than 9,743. Okay, again, I don't want to look at the numbers yet. I just want to think about how I would set it up. If I wanted to look at the relationship between the 2015 number, the 2014 number, and the percentage change, it would look something like this. I'd take new over old, 2015 over 2014, and subtract 1 to get the percentage change. So again, I want you to think, looking at this, what's the value we should be using for percentage change? Answer me on the form. So my percentage change is 7%, but it's a 7% decrease. So the value I need to use for percentage change is negative 0.07. So be on the lookout for those decreases and pay attention to them. Okay. Now I'm going to actually take this over to paper to finish it off. So after you watch this video, you should be sure to look over your homework and see if there are any other questions that you were confused by that now hopefully make a little more sense. So let's pick this problem up. Again, here's just a statement of the problem, and what we just said is the 2015 number divided by the 2014 number minus 1 has to be equal to negative 0.07. Negative because of a decrease, and then I take this 7% and I turn it into 0.07. So I'm going to plug in the value that I know. I am given the 2015 value, and then I want to solve for the 2014 value. So let's plug that in. 9,743 divided by this unknown 2014 number, subtract 1 from that, and I would get negative 0.07. And at this point, it's an algebra problem. This is essentially our x, our unknown, or thing that we're trying to solve for. So first I'm going to add 1 to both sides of the equation in order to get rid of that part. And I'll be looking at 9,743 divided by this 2014 number is equal to negative 0.07 plus 1, which is 0.93. Incidentally, this means something. it means that the 2015 value is 93% of the 2014 value. Anyhow, now I'm going to multiply both sides by this unknown, this 2014 number, in order to clear that denominator. And I get 9,743 is equal to 0.93 times this thing that I want to know, the 2014 number. So finally, I'm going to divide both sides by this in order to get my answer, which is 9,743 divided by 0.93 has to be equal to my 2014 number. And at this point, I can just pull out my calculator and get the answer. The number of crimes, of robberies, excuse me, in New Jersey in 2014 is 10,476 robberies. And finishing off with my quick reality check, that is indeed bigger than 9,743, so at least it's a plausible answer. So we're often going to see problems like this where you're given the percentage change and one of the other two values. It might be the top one, it might be the bottom one. You have to think carefully about how you would set it up and then solve for the missing number. Thank you.